this is the worksheet on the back of the reaction quotient notes. So it starts off just reviewing sort of here KEQ and what that means, and this is to help you see the difference between KEQ and Q. So it says here, which reaction contains mostly products at equilibrium, and explain. And so mostly products, meaning that it's product favored, the way that that relates to KEQ is that if it's got a KEQ of more than one, it's going to be product favored. So this is reaction B. Which means also here, because KEQ, as we said, is greater than 1, it's product favored. So KEQ greater than 1, and this is product favored. So for this one, it says which reaction mostly contains reactants, and explain. It's just the other one, so reaction A. And this is because for reaction K, KEQ is less than 1, which means it is reactant favored. Which reaction's equilibrium lies to the right? Well, to the right means on the product side, because when we say to the right or the left, we're talking about if you're looking at an equilibrium reaction. And so to the right, the one that's product favored, that would be reaction B. All right, so now we're going to do some problems involving the Q here. So on this one it says, which is greater at equilibrium, products or reactants? So we look at the KEQ. Again, the KEQ is greater than 1. So that means that it is going to be product favored. Scrolling down here, so what we're going to do now is calculate the actual Q. If you look at the reaction above, you see that Q equals H2O to the third, H2O cubed, oops, times CO2 squared over C6 H6O times O2 squared. Plugging numbers in here, we have 3.9 to the third times 0.88 squared over 0.012 times concentration of O2 is 0.1 squared. Go through and calculate that. You should get something like 382,805. All right, and if we compare this to the KEQ up above, the KEQ is 2.658. All right, and so what we're doing with this Q, we're testing, we're seeing if it's at equilibrium. The Q is really, really large. That means for the Q, the numerator, the top, is too large and the denominator is too small, which means we need to make more reactants, less products, which means that we're going to proceed left. So since Q here is going to be greater, Q is greater than KEQ, so the reaction proceeds left. All right, for this last problem here, it says we've got this unbalanced reaction. It gives us KEQ. This one's a really small KEQ, so that means that it is reactant favored. So we calculate Q again to figure out whether we're at equilibrium or whether we need to go towards the products of the reactants. Q is equal to NH3 squared over N2 times H2 to the third. Oh, you might be a little bit confused where I was getting those exponents. This said consider the unbalanced reaction up above. So what you need to do is you need to go ahead and balance it. So to balance it, we need a 2 in front of the NH3. We need a 3 in front of the H2. And so that's kind of where that's coming from. All right, so going through, plugging in the numbers here, we get 3.9 to the third. Times, over concentration of N2 is 0.25. Concentration of H2 is 4.53. And that one is cubed. Oh, this one up here should have been squared. Sorry about that. Calculate that. You should get something like 1.2 times 10 to the negative 8th, or it should be 0.0000000012. Okay, 7 zeros. And then we compare that to KEQ. We see here that Q equals KEQ, which means that we have a situation where we're at equilibrium. I know that wasn't a lot of practice on those. There'll be more on the review, more on the practice exam, so make sure that you're kind of looking through that and that you understand, and if you don't, come in.